A very good evening to you all and welcome to today's class. Today we'll be looking at Module 3 of the CCNA1 networking class. We'll be looking at the topic protocols and models. If you are joining us for the first time, I implore you to check the YouTube link and ensure that you follow up with Module 1 and Module 2 so that you can comprehend Module 3. Okay, so let's go into it. During this topic for today, we'll be looking at the concept of rules. We'll also be looking at protocols. We'll be looking at protocol suites, standard organizations, reference models, data encapsulations, and data access. After our class today, after the presentation, we'll be looking at 2 lab activities. We'll be looking at 1 lab activity and a packet tracer lab activity as well. Okay, and then I will drop an assignment for you to work on. Okay, rules. Communication is a very important component in rules, okay? It is what established between sender and receiver. If there is a communication that is happening, there must be a sender, there must be a receiver, and then there must be a medium, okay? That is what we have looked at. Now, these protocols are basically rules that are set aside to ensure that there is understanding or effective communication between a sender and a receiver. So protocols must account for the following requirements. 1, an identified sender and a receiver. So I must have, let's say, a sender, and then I must have maybe a receiver. Then I will have maybe a medium, which I'm going to use to communicate. So number 1, you must have a sender and a receiver. Number 2, you must have a common language or a grammar. When we're talking about protocols, we're talking about the rules of communication. So the common language or grammar here means that the protocol that the sender is using must be the same protocol that the receiver is using as well. Okay, then number 3, speed and timing of delivery. This is also a very important requirement. Then finally, confirmation or acknowledgement requirements. So common computer protocols must be in agreement to include the following requirement: message encoding. When we're talking about encoding, we're talking about how that message is packaged into the network media. All right. Remember, we said we have a PC here, we have a PC, then you have the network media. So how does the message from this sender sent or encoded into the media? So there are rules or there are protocols that governs that. Then we have message formatting and encapsulation. When we're talking about formatting, we're talking about how the message is packaged and presented. Okay, encapsulation, we will talk about encapsulation very soon. It's just the process of adding header information. We will see about that very soon. Then you will have a rule that talks about the message size. What is the maximum size that can be sent through a particular channel? What is the minimum size that can be sent? So there are rules for that. Then you have the message timing. There are rules for that. And then the message delivery option as well. So we say encoding is the process of converting information into another acceptable form for transmission. And decoding is like the reverse of the process. So you have a source, And that source, that message must be encoded into the medium before it's sent. So the process of encoding and decoding have to work hand in hand. And then when a message is sent, it must use a specific format or structure. It's like when you are writing a letter, you want to send it via the post office. There must be a format that you're going to use in writing. So the format depends on the type of the message and the channel that you're supposed to use. Now, additionally, there's what we call the header information. We're going to see in this topic today that there are different levels of messages when it comes to communication. There are different layers that the message have to pass through. And so, because there are different layers the message have to pass through, this message is formatted from the sender in a particular layer to a receiver at the same corresponding layer. So if the message is formatted for a sender in layer 1, when it gets to the receiver, that particular format is interpreted for the receiver in layer 1. But because the message have to go through different layers, there's what we call header information. And they're just basically details that are carried along with the letter. So this person writes a love letter for Jane. Dear Jane, I just returned from my trip and I thought you might like to see the pictures. That is the message. Okay, but inside that message will be enveloped. And once the message is enveloped, inside this envelope, observe what happens. There must be a header information on the envelope. It will tell you the sender, it will tell you the recipient on the envelope. So this is now what we call the header information, the information that is at the back. So in networking, we have like certain information that are being conveyed in header. So the process of adding this header information as you move across the different layers is what we call the encapsulation process. Then when we talk about messaging size, the encoding between hosts must be in an appropriate format for the medium. Messages sent across the network are converted into bits. Why are they converted into bits? Because binary is the language of the computer. Okay, so binary is like zeros and ones, bits, binary digits. So the bits are encoded into a pattern of light, sound, or electrical impulses. Why? Because those are the different medium that are used in the particular a channel of communication, right? So if you're using converted into light, which means you're using fiber optic medium. If you are converting it into sound, or you are converting it into wireless medium or electromagnetic wave, that means you have another particular thing. If you're converting into electrical impulses, you're also using maybe another type of medium. Okay, so maybe sound, will talk about microphone and speakers. And electrical impulses is talking about you're using copper cable as your network medium. Message timing. So the message timing includes the flow control. The flow control actually manages the rate of data transmission and defines how much information can be sent and the speed at which it can be delivered. The response timeout manages how long a device waits when it does not hear a reply from the destination. Access method determines when someone can send a message. And there may be various rules governing issues like when there is a collision in the message, or when more than one device sends traffic at the same time and the message becomes corrupt and things like that. So some protocols are proactive and attempt to prevent collision. Other protocols are reactive to establish a recovery method after the collision. So remember, what we are talking about is the rules that are engaged in the delivery, sending and delivery of messages. Now, what are the various delivery options? We have three. We have what we call unicast. Unicast is what we call one-to-one communication, when a sender is sending a message to a receiver, which means you have the message for the receiver. You know the destination, you know the address of the receiver and things like that. So you address the message to the receiver. So it's like saying, I am sending a message to Victor. Okay, so Victor knows that I am talking to him. Multicast is now saying you are sending one to many, which means the source is sending to a group of receivers. Okay, so I can say maybe I'm sending a message to the men in this class. All right, so you see in this class there are men, there are women. Okay, but I am sending it to the men in this class. That means there is a group of people that this message is meant for. So that is what they call multicast. And then when I say broadcast, I'm sending one to all. The source is sending to every node that is on the network. So it's like saying I'm sending message to the entire class. Okay, I'm sending message to the entire class, which means I'm sending a broadcast. So generally communications work on that. So let's take a deeper look at the protocols. Network protocols have different functions. Okay, device use agreed upon protocols to communicate. Because if this guy is a sender and he wants to talk with this particular server, it says that I will send this message across the network using IP version 4 header. That is a protocol. That is a rule. That is an agreement that is sending. Then the server is saying, I can accept this message because I understand IP version 4 protocol. That is what the server is saying. How about the intermediary devices, the routers? They are saying that I can forward this message because I understand IP version 4 header as well. So you see, there is now an understanding amongst all of them when it comes to the issue of that. Okay, so addressing function identifies sender and receiver. So you cannot send a message if you don't know who you are sending it to. That is one of the rules. Reliability provides guarantee of the delivery. There is a particular protocol that talks about your reliability of message. Then you have flow control that ensures that data flow at an efficient rate. And this controls based on the speed of the network or the congestion in the network and things like that. Sequencing uniquely labels each transmitted segment of data. Okay, error detection determines if data becomes corrupted during transmission. What happens? What happens if there is an error in transmission? Is it going to drop the data? Is it going to resend it? Or is it going to report back to you? Or what happens? There are rules that governs that, and those are the protocols. And then we have the application interface that process communication between network applications. Okay, so we are made to understand that in order to enhance this end-to-end communication between a sender and a receiver, between a client and a server, these protocols have to learn to talk to each other. They have to interact amongst themselves. And a particular single message that is being sent across the channel may actually need to interface with multiple protocols. Maybe Ethernet protocol, IP protocol, TCP protocol, HTTP protocol, all of them. All these protocols are playing a key role when a single message is sent. Why? Because each one of them have their functions. They have the role that they play, all right? And we are going to see the roles that all these protocols face. And to understand the role, we need to understand the concept of protocol suites. The protocol suite. Now, how did the protocol suites come about? There are several protocol suites, okay? There are several of them. We have what we call the Internet Protocol suite or the TCP/IP protocol suite. And that is the most common protocol suite and maintained by the Internet Engineering Task Force. They're the ones that manage this protocol suite. And that particular protocol suite has only 4 layers. We're going to look at that particular protocol suite. Okay, this is the protocol suite. And in the protocol suite, out of the 4 layers, it says that the first layer is called the network access layer. Okay, and that network access layer runs these protocols, Ethernet, ARP, wireless LAN, and things like that. What does it do basically? The network access layer is the layer that actually controls how the device connects to the network and how messages are sent through the network media. So it interfaces between the network media and the device itself, whether the sending device or the receiving device. So that's the network access, and that is the layer 1. The layer 2 of the TCP/IP is called the Internet Protocol. And the Internet Protocol is concerned with how the message is routed across the network or across the internet. Okay, and there are protocols that run relating to that. And they are typically IP version 4 protocol, IP version 6 protocols. Okay, and then we also have ICMP version 4 and version 6 and things like that. So that is what runs on the Internet Protocol. For the layer 3, it runs what we call the transport protocol. And in the transport protocol, it is concerned about or concerned with the size of the message as it is sent through the network media. It is also concerned about the security of the message as it is being sent between sender and receiver. It is also worried or concerned about how that message is transported over the channel of communication. And it runs basically 2 protocols, TCP protocols and the UDP protocol. Then you also have the application layer, which is the 4th layer. And the application layer usually is the layer that you generate the message. This is where you now create the message. And it runs applications or services generally, maybe HTTP, DNS, DHCP, FTP. It runs services majorly. So you see, that is the TCP/IP protocol. The next protocol is the OSI model protocol, which is the Open System Interconnection. And it is developed by the International Organization for Standardization and the International Telecommunication Union, all right? And that particular protocol, we're going to see very soon how it relates with the TCP/IP protocol. The OSI protocol has 7 layers, okay? But like we said, for the TCP protocol IP suite, it has 4 layers, 1, 2, 3, and 4 for the TCP, right? Let's not forget that, okay? And for the OSI, we're going to see that, where is it? Let me just go there. The OSI model has 7 layers. These are the 7 layers. It has layer 1, physical, layer 2, data link, layer 3, network, layer 4, transport, layer 5, session, layer 6, presentation, layer 7, application. We're going to look at each of these layers in details. In fact, each of the layers is a chapter of this course on its own. Like what we're going to be looking at tomorrow will be chapter 4, and chapter 4 will be physical layer. We're going to find out more about that. But before then, let us understand the concept of internet standards. Internet standards. The internet standards, we have something like called the Internet Society. The Internet Society actually promotes the open development and evolution of the internet. And they have different chapters across the countries. So we have Internet Society Nigeria chapter, and it is very free for you to join, to be a member. In fact, it's part of the assignment I'm going to drop with you after the class. I'm going to drop a YouTube link, a recording that I have done on how you can join to be a member of Internet Society. And I'll strongly advocate that you register and join the Nigeria chapter so that you can be part of the internet development. You can be part of the internet growth and things like that. Okay. Then you have the Internet Architecture Board. The Internet Architecture Board. Then under the Internet Architecture Board, you have the Internet Engineering Task Force. All right. And you also have the Internet Research Task Force. Under the Internet Engineering Task Force, you have different working groups. Under the Internet Research Task Force, you have different research groups. And these are different individuals or people that contribute knowledge to the growth of the internet and to the shaping of this internet. For instance, the Internet Engineering, the Internet Architecture Board is responsible for the management and development of internet standards. Okay, there are different standards. So those are the people responsible for it. And the Internet Engineering Task Force is actually people that develop updates and maintains internet and the TCP/IP technologies as well. And those in the research section focus on actually long-term research related to internet and TCP protocols. Okay. Now, standard organizations are involved with the development and support of this particular TCP/IP. For instance, we have what we call the IANA. All right. The IANA actually stands for Internet Assigned Number Authority. Internet Assigned Number Authority. And they basically oversee and manage IP addresses allocation, domain names that you know, and the protocol identifiers and things like that. Okay. And they work hand in hand with the ICANN, which is the Internet Corporation for Assigned Names and Numbers. And what they do is coordinate IP allocation and things like that. So the issue of who gets what type of IP address, when you register for a domain name, maybe like the domain name of your school or your organization or your personal one, you know, they manage that. And then the issue of port numbers. We're going to look at each one of these in details in much subsequent topics, okay? So, like we said earlier, the OSI model has 7 layers, and these layers are having relationship with the TCP/IP layer, which is 4. 1, 2, 3, and 4. Now, you'll see that the layer 1 of the TCP/IP corresponds to layer 1 and layer 2 of the OSI model, but they all do the same thing. Okay, they control what happens between your data and the network media and how the data is formatted and interpreted. Okay, and they run protocols like Ethernet, wireless LAN, SONET, and things like that. Layer 2 of the TCP/IP, which is internet layer, corresponds to the layer 3 of the OSI model, which is the network layer, and they do the same thing. They run the same protocols. The difference between the two is that in the TCP/IP model, it talks about the internet, which means it controls traffic between different networks, interconnection of networks across the internet. But for the OSI, it controls or gives details about communication between end devices, between two systems. When you form even a local network, if you form a small network between two systems, all right, it covers it. So it does not necessarily mean inter-network. It includes intranet, extranet, and internet as well. Then layer 3 of the TCP/IP corresponds to the layer 4 of the OSI model, and both of them run TCP and UDP, and they perform the same thing. Like for those of you who are really interested in cybersecurity, your attention will be mostly on OSI model layer 3 and layer 4. That is the network and the transport layer. Okay, these two layers, particularly, especially the transport layer. So, because that is where the manipulation of data is, controlling how the data moves, how things happen, and things like that. Then now look at in the TCP model, layer 4 correspond to layer 5, 6, and 7 of the OSI, which is the session, presentation, and application layer. And those particular layers covers majorly the services that are created and are being rendered. HTTP, DNS, DHCP, FTP, and so on and so forth. So those particular layers have their relationship. But one thing you should know, all these things are just but reference models. They are just to help you understand the communication between two devices from a sender to a receiver, basically. So if I am sending a message from one point to the other, how does my message move? How does it move across the board? That is what these particular models are explaining, okay? So they assist in protocol design because protocols that operate at a specific layer have defined information that they act upon and a defined interface to the layer above. Okay, so another benefit is that they foster competition because products from different vendors can work together. So when they build all these particular layers and these standards, every vendor that produces devices, maybe like network devices, let's say Cisco, HP, Juniper, Mikrotik, all these vendors that you know, okay, they have particular standards that are there, right? So those are the models. So in the OSI, like we said, the physical layer describes, which is the layer 1, describe the means to activate and maintain and even deactivate physical connections where your cables is connected or you connect wirelessly or you use fiber optic or whatever it is. Data link describe method for exchanging data frames over the network media or the common media. Then the network layer provides services to exchange the individual piece of data over the network. Transport layer defines services to segment, transfer, and reassemble the data from individual communication. Session layer provides services to the presentation layer and to manage data exchange. Then presentation layer provides for common representation of the data transferred between the application layer services. Application layer contains protocols used for process-to-process communication. So we are saying that if I am having a PC here, one, and this PC is sending a message to another PC2, and there is an intermediary device here. This is a switch, then this is a router, okay? Which means in this particular PC, all these layers from layer 7 to 1 will run. In other words, there will be encapsulation. The message will be created at the application layer and then be sent to presentation layer, will present it in a way it should present. It will compress it and things like that and encrypt it. Then session layer will now open the dialogue for the communication. All right. That's what the session layer will do. Open the dialogue and manage the dialogue to ensure that message can be sent across. Then transport layer will now provide the medium in terms of the port number that will be used to start the communication, and then package the size of the message based on this maximum segment size. The network layer will now get the source IP address and the destination IP address. The transport layer also get the source port number and the destination port number. Then when it comes to the data link, it also gets the source MAC address and the destination MAC address. And then by the time it comes to the physical layer, it will now format it in a way that it will be sent across the medium that is connected to this particular PC. Now, Once the message goes through the medium, it gets to this particular device. This switch is a layer 2 device, which means there would be a decapsulation process at that particular point. And the decapsulation process, since this is a layer 2 device, the information that is encapsulated at a layer 2 will be interpreted for this guy here. And then there will be encapsulation. It gets to the router. The router is a layer 3 device. Then there will be decapsulation to layer 3. And then this router will get the message that is packaged for it from the sender. Okay, then it will re-encapsulate again. By the time it gets to the receiver, the message will be decapsulated from layer 1 down up to layer 7, where they are going to get the main source of the message. So that is what happens at the OSI model. At the same time, happens at the TCP/IP model. And you may want to know, what is the difference? The TCP/IP model is the older version, because if you see that, it is the same thing. The only difference is that the OSI model has more detail. It is more detailed than the TCP/IP model, right? I think we have looked at that. Now, data encapsulation says that segmenting is the process of breaking up messages into smaller units. And multiplexing is the process of making multiple streams of segmented data and interleaving them together. So segmenting messages has two primary benefits. One, to increase speeds, and then to increase efficiency. Who handles this segmentation? It is the transport layer. Because this guy is sending message, this guy is sending message, and the size of the message on the media varies. So segmenting is saying that, okay, based on this size of the message, we're going to segment it into probably 1, 2, 3, 4. So you will send the first segment, then you send the second segment, send the third one, and the fourth. So by the time they all arrive at the destination, that is when then they will be reassembled, and then the message will be. So this is basically what happens. So each one of them have a sequence number or a segment number. Okay, so sequencing messages is the process of numbering the segments so that the message would be reassembled at the destination. Okay, so TCP is responsible for this sequencing of individual segments, and that TCP functions at the transport layer. Okay. Now, we said this earlier on, that encapsulation is the process where protocols add their information to the data. So at each stage of the process, the PDU simply means portable data unit, okay? The PDU has a different name and reflects a new function, which means that in each layer, as the message goes either from application layer down to physical layer, the PDU has different name. For instance, in the application presentation and session layer, the PDU is known as data. It's called data. Okay, but in the transport layer, the PDU is called segment. In the network layer, it is called packet. In the data link layer, it's called frame. And in the physical layer, it's called bits. So when you talk about encapsulation, you are saying that this guy, for instance, generates an email, and that email is like the data. Okay, data because it is in the application layer. So after this data is formatted and packaged and compressed based on the presentation and session layer, then it sends this entire data. This entire data is encapsulated. Look at it here. And is sent to the transport layer. The transport layer now adds its own. This is the addition that the transport layer will add. It will add a transport header. What is inside the transport header? We're going to find out very soon in another class. But basically, it talks about the protocol that is there. it talks about the port number of the source and the destination, and some other small details like the segment size, the maximum message segment, and things like that. Okay, and it is packaging that information for the transport layer at the receiving end. Okay, so after that, then both the header and the message are grouped together and sent down to the network layer as data. So it arrives as data. So you see the transport layer and the data comes down to the network layer. The network layer will now add its own header information. So this process is the encapsulation. So it has its own header information. And what are the kind of header information you find in the network layer? Maybe the source IP address, the destination's IP address, you know, if it is a version 4 or version 6 and things like that. And details relating to the network layer, which we're going to see in another topic, okay? And then it is adding this information because the message will get to the receiver, and there is a device that deals with the network layer device, which is a router. All right. Then after that, it comes to the frame, which is the data link. But you see that this whole thing is dropped down. Once it drops down, the frame will now add its own frame header and then maybe a frame trailer. The frame header actually contains its own information, and the information is about the MAC address of the sender and the MAC address of the next device. It also contains some other information about it. The frame trailer contains basically like error detection, cyclic redundancy check, and things like that, just to ensure that the size of the entire frame is not altered. It is after this whole thing that it will now be converted into bits before sending it through the network media. So that is how it's done. This is like an example of the encapsulation. So in the encapsulation, you have your data, then TCP header, IP header, frame header. So you have all this information sent across the network. And then when it comes to the receiving end, it has come to the receiver. The receiver will receive it in binary like this. And then it will now begin to decapsulate it and then get the main message. We are going to have lab activities now, and in the lab activity, we are going to have two. One is a packet tracer, which you're going to see how messages are sent and then how it happens across the layer. Then the second one, we'll use like a Wireshark to see how we can interpret some few things. All right, so just hold on with me. Let me launch the packet tracer. Okay, where's the packet tracer? Right, let me share it. Right, sharing. All right, so you should be able to see the packet tracer now. And the packet tracer we're doing is the packet tracer for 3.5.5, okay, in the list of packet tracer activities that you have. So I'm sure some of you probably must have done it, but for those that maybe did it, have challenge, or who have not done it, this is it. Now, in this particular packet tracer, we are going to investigate the TCP IP and the OSI model in action. We're going to now do two parts. Part one will examine the HTTP web traffic. You know, the HTTP is a service at the application layer. So, and it is a protocol. So we're going to examine it, the traffic. And then part two, we're going to display the elements of the protocol suite, the elements of the protocol. So that's what we're going to display, right? Okay. The background information, let's quickly read it so that we can understand what we're going into. It says that this simulation activities is intended to provide a foundation for understanding of the TCP/IP protocol suite and the relationship to the OSI model. Simulation mode allows you to view data content being sent across each of the layer. Okay, and it says that as data moves through the network, it is broken down into smaller pieces and identified so that the piece can be put back together when they arrive at the destination, right? We said each piece is assigned a specific name, which is a protocol data unit or PDU, and associated with specific layer of the TCP/IP and OSL models. Packet tracer simulation modes enable you to view each of the layers and the associated PDUs. Now we said that the following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on the client PC. Okay, and we said even though much of the information displayed will be discussed in detail later, this is an opportunity to explore the functionality of Packet Tracer and ability to visualize the encapsulation process. Okay, so that is the background of what we're going to be doing. Then we have the instructions on how to go about it. We have the part 1. We're going to examine the web traffic. Okay, so how do we do that? Let's go to step 1. It says switch from real-time mode to simulation mode. And where do we find these modes? Okay, these modes are found on your packet tracer. Let me shift it. You see, this is on your packet tracer. There's the real-time mode. Then there's a simulation mode, right? So let me put this one here. So we are being asked to click the simulation mode icon and switch from real-time to simulation mode. So I'll click here. So you see the moment you click, it brings out a particular...
Hello, sir. You're not really seeing what you're clicking on.
You're not seeing what I'm doing?
Yes, sir. You said you're clicking on simulation and real time. Okay, it's showing now.
Okay. All right. So this is the environment that once we begin the transmission of data from source to destination or from sender to receiver, you're going to see it displayed here. And then the OSI model will also, we're going to investigate it using the OSI model. Then step 2, okay, where are we? B says select HTTP from the event list filters. This is HTTP. And you see, this is HTTP. It's already selected. But in case, it says HTTP may be the only visible event. If necessary, click Edit Filters button at the bottom of the simulation panel to display the available visible events. All right. What we are saying is that in case in your own activity you did not see HTTP, all you just need to do is click these Edit Filters. If you click Edit Filters, you see some other applications. If you click this MISC, you'll see all these applications. So far, it's only HTTP we picked. So if your own, you didn't see HTTP, you will just come and click the HTTP here, and then you will be fine. All right. So we have HTTP is already clicked. So we are okay. And then 2 says select all to toggle. Okay, that is in case you didn't see HTTP, you can actually do that. All right. Then step 2, it says generate web traffic. Currently, the simulation panel is empty. There are 5 columns listed across the top of the event list within the simulation panel. Look at them. This is 1, this is 2, this is 3, this is 4, and this is 5 column. And so each of these columns is going to display an information, so we should take note. It says, note, the web server and web client are displayed at the left plane So the panels can be adjusted in size by hovering next to the scroll bar and dragging left or right when the double-headed arrow appears, right? This is where our server and our client is that we're going to use, right? So it's just to let you know. Now, A here says we should click web clients in the far left plane. That is this web client. So let me click web clients, right? So we have click web clients. Let me shift this one here so that we can be seeing the things. This is the web clients, right? We have clicked the web client here. It says click the desktop tab. Click the desktop tab and click the web browser icon to open it. This is the desktop tab. And then where's the web browser? This is web browser. I click. Let me be sure if you can see what I'm doing.
Can't see what you click on.
Okay.
We are not seeing it. We are not seeing it, sir.
All right. Let me just share my entire screen so that as I switch over, it would be easier to understand. Okay. So I believe you should be able to be seeing my screen now. You should see everything I'm doing. All right.
Yeah, we are seeing
You can see the screen, sir.
Now.
Also, please hide your image, hide your picture, please. It's covering some parts.
My picture, I should hide, is not open.
You just not showing your
But I'm seeing your picture.
You are
No,
seeing.
you just not showing it. There's no
We
picture.
can see it. It is clear now, sir.
Oh.
All right. So if I click desktop, it brings us to browser here. If we click browser,
Did you get to that desktop? Sorry, sir.
yeah.
How did you get to the desktop?
Can you go back a little, sir, so we can know how you get to the desktop?
All right.
Yes.
Let me come to the instruction again. This is where we are. We said click the web client in the far left plane. Okay. And then this is the web client. Where is it? This is the web client here. They say we should click it. So I click the web client. Let me drag it here. Can you see it here? Then it says, B says, click the desktop tab and click the web browser icon. Okay. So this is the desktop tab and then the web browser icon. Okay. Let me click top here as well. So I've clicked the web browser icon. This is where it is. All right. Then C says in the URL field, enter this website, www.osi.local, and then click go. So we should come to this URL and put this, and then we should click go. Okay. Now, it says, because time in simulation mode is event-driven, you must use the capture forward button to display network events. The capture forward button is located at the left-hand side of the blue band that is below the topology window. Of the three buttons, there is one on the top right. So they're giving us description where we're going to see the capture button. So this is it. Can you see? This is where we have these capture buttons here. These are where we have the capture buttons. All right. So we are going to do what they said. So D says click the capture forward 4 times. There should be 4 events in the event list. So let me minimize this and then click it 4 times. Once we are clicking it 4 times, you will observe what is going to be happening here. So if I click next, can you see? We're going to investigate what happens there. If I click this again, All right. In fact, let me minimize this so that you see this is the message that is going again because it has just left the client that's come to this server. So now from the server, it will go back. Can you see? It will go back. And then the fourth one, we have done it. This is the four times they say we should click and which we have done. This is the information we are going to now investigate, right? Once we have done that, see the results that came from the web server. Because we launched this, we put this address and we click go. So the 4 that we clicked, it says you have successfully accessed the home page, blah, blah. That means it's like somebody has browsed a page. Okay. Now, let's go back to the information, to the instructions and see what happens. It says, look at the web client page. Did you see anything change? The answer is yes. This is what has changed. This is what we have seen here. Okay. E says, click the first colored square box under the event list. All right. Under the type column, it may be necessary to expand the simulation panel or use the sidebar event list. So I'll drag this here. This is where they are saying we should click the first colored square box. This is the first colored square box. And you see, if I click it here, you see, if I click it, it brings another window for me here. Too many windows. So let me minimize this one. Right? So it brings this particular window. So you see in this window, it has brought from layer 1 to 7. So we are going to find out what is happening here. It says that the PDU information at device. It says web client window displays. In the window, there are only 2 tabs, the OSI model and the outbound details. This is the OSI model, which is what is displayed here. And then the outbound details. This is the outbound details. If we click it, these are the details. We're going to find out what are all these details and what information is there. Okay. It says, because this is the start of transmission, as more events are examined, there will be 3 tabs displayed, adding a tab for inbound PDU details. When the event is the last event in the stream or traffic, only the OSI model and the inbound PDU detail tabs are displayed, right? F says ensure that the OSI model tab is selected, which we have done. We're selected now. It says under the out layers column, click layer 7. This is layer 7. So if I click layer 7 here under the out layers, I've clicked layer 7. All right. It says what information is listed in the number step directly below. All right. Below the layer, in the layers and out layer boxes of layer 7. This is it. These are the information. The HTTP client sends requests to the server. That's the information. All right. Under this guy here, the HTTP sends request to the server. It says, what is the destination port value for layer 4 under the out layers? This is layer 4 here. Can you see the destination port? We're saying the source port is 1025. The destination port is port 80. And the information here is a sent segment information. The sequence number 1, acknowledgement number 1, and then data length is 102. But the source and destination port is this, right? There it says, what is the destination IP value for layer 3? So under layer 3, if I click here, it gives me the source IP address as 192.168.1.1. The destination IP address is this. You see, we are in, this is not what on a normal day you will see when you are communicating, but this is like a translation of what actually happens when a packet is intercepted. These are like the details that are there. Okay. So it says that the destination IP address is in the same subnet. So the device sets the next hop to the destination. That is what happens here. Then goes down here. It says what information is displayed in the layer 2. This is the layer 2. And then the layer 2 talks about the MAC address of the source and MAC address of the sender. All right, because you see there are two devices here. So the MAC address of the source and the MAC address of the receiver. Okay, so that is what you see here. And then it says, G says, click the outbound PDU tab. So if we click the outbound PDU tab, let's find out what is here. It says information listed under the PDU format is reflective of the layers within the TCP IP model, which is correct. Okay, so for instance, this is layer 2. Can you see under Ethernet? And then it's telling us the header information and the details. This is the trailer, FCS trailer. This is the header information. All right. And then it will tell you the destination MAC address. You see, this is the destination MAC address. You see, this is the source MAC address. This is the data that is there. And then this is the IP header. Under the IP header, it will tell you the version 4. It tells you the TTL. All right, the TTL is 128. It tells you the checksum where there are errors or something. It tells you the source IP address. It tells you the destination IP address. It tells you the data that is also there. And then for the layer 4, it tells you the source port number. It tells you the destination port number. It tells you the sequence number. These are header information. So this header information is what is added to the message. Then tells you the acknowledgement number, tells you the checksum, the window size. We'll talk about all these details in the chapter. So each of these layers is a chapter on its own. Okay. And then this is the HTTP request at the application and the application layer. So you see, that is what we are able to see here. Now, in part 2, it says we should display elements of the TCP IP protocol suite. All right. So go to event list, visible events, and click show all. Right. So here it's saying we should click show all. If I click here, you see, it's going to now display all the details. Can you see of what transpired? There's a DNS, there's an ARP. So you see under the DNS is a layer 7 application because it was trying to look for the domain name. So it says that the DNS client sends a DNS query to the DNS server. Okay. And then under ARP, here, address resolution protocol, it says that the ARP process construct request for the target IP address, and ARP happens at layer 2, and that is why you see it here at layer 2. So the point of this activity is for you to understand that between the source and the destination, there are a lot of activities that happens across the OSI model layer. And that is what it explains. It explains what happens between the source and what happened to the destination. Okay, that is for this activity. The next activity we're going to do is on Wireshark. All right. Now we are supposed to install Wireshark. I'm going to drop for you steps to install it on your machine. You can download and install Wireshark. All right. And in this particular activity, we're just supposed to use Wireshark to view the network traffic. on this particular kind of system. So you see that we have a router here that is connected to the internet, and then it's connected to a switch where you have some other systems. Now, the objective of this particular activity is to capture and analyze local live traffic or traffic or something like that, and then analyze, capture, analyze remote ICMP data in Wireshark as well. And then there's a background scenario. It says Wireshark is a software protocol analyzer or a packet sniffer, right? And application that is used for network troubleshooting and analysis, all right? As data streams travel back and forth over the network, the sniffer captures each protocol data unit and can decode and analyze its content according to the appropriate RFC or other specification. Wireshark is a useful tool for everyone working with network and can be used with the most labs in the CCNA course for data analysis and troubleshooting. And we said in this lab, you will use Wireshark to capture ICMP data packet. What is this ICMP? That's like ping. You like ping, when you ping, it carries the protocol that ensures that you can reach your destination and back. And what do you need for this lab activity? You need one PC with internet access. I will use my laptop for that. You say you need another additional PC on the local network that you are going to ping with. I don't have an additional PC now, but I can connect my phone and then use it as an end device. All right. Now, what is the instruction? We're supposed to capture and analyze local ICMP data in Wireshark. So it says in part 1 of this lab, you will ping PC on the LAN and capture the ICMP replies in the Wireshark. You will also look inside the frame captured for specific information. So this analysis should help to clarify how packet headers are used to transport data to their own destination. All right, so we're going to do that. So how do we go about it? Step 1, for this lab, you need to retrieve your PC's IP address and its network interface card. So how do you do that? You go to your command prompt and then you just type this command, ipconfig/all. This is it here. Just type the command. So let's do it. If I come to run here and I do ipconfig/all, and let's see the information. So you see, these are the information on my own system. And I want you to take note of it because we're going to come to it. You see here, it says the IP version 4 address. This is the IP version 4 address of my system, 192.168.28.192. Okay. This is the MAC address that I am using for my wireless. This is the MAC address. This is the IP address, right? And then this is my default gateway, 192.168.28.106. This is my default gateway, all right? And the same as my DNS server. So we've gotten this information. This is the same information that we are supposed to get, right? Then step 2 says start a Wireshark and start capturing data. Okay, so like I said, I'm going to drop for you on the WhatsApp the activity to download and install, how to install the Wireshark. You will do. So assuming you've done that, so I'm going to now launch my Wireshark. This is my Wireshark, so it's going to load now. Right, so my Wireshark is loading. It has loaded. So I'm not going to capture on local interface. I'm going to capture on my Wi-Fi. That's why I'm selecting Wi-Fi here, my Wi-Fi here. So let's check the information. It says navigate to the desired Wireshark and you start capture, right? Now, let's go back to it. So the next thing is just for us to start capture, right? So when we start capture, then we will come and run a ping. I'm going to ping maybe my gateway or ping another system. That's what they want us to do. So here, how do I start capture? You see here, where is this blue here by the top left-hand corner? If I click here, I've started capture, okay? Then I will come to my command prompt where I am doing ping. Then I'm going to now ping my gateway. All right, this is my gateway. You see it here? So I'm going to ping it while the traffic is capturing now. So I'm going to ping 192.168.106. Okay, so you see it is currently pinging. That means the what do they call it now? The Wireshark should be capturing it now. I'm sure it has been capturing it, or it is currently capturing it. Then let's go back to the information, to the, what do they call it now? To our activity and see what we've been asked to do. All right. So it says, before we go there, we need to go to filter box. Type ICMP in the filter box at the top of the Wireshark and then apply. Right? So where's our Wireshark that is capturing? So let me stop it now. So I'll go to the filter. Can you see filter? I'll just type ICMP. Right? Once I press enter, this is the ICMP packets that has been, can you see the protocol here? Protocol here, this is ICMP packet that has been captured. The ping that we did, and you see is a ping that we did, so it has been captured here. So let's see what else that the activity has asked us to do. It says that, look at it. This is what we have gotten, right? Now, it says, examine the captured data. In step 3, examine the data that is generated by the ping request of your team PC. Wireshark data is displayed in 3 sections. The top section displays the list of the PDU frames captured with a summary of the IP packet information listed. 2, the middle section lists the PDU information for the frame selected in the top of the screen captured. All right. And 3, the bottom section displays the raw data. So let me show you the 3 segments. Can you see here? This is the first segment. All right. Then this is the second segment. Then this is the third segment. All right. So let's see. A says, click the ICMP request PDU frame at the top section of the Wireshark. Notice that the source column has your PC's IP address and the destination column contains the IP address of the teammates that you pinged. Okay, so that means if I pick something here, you see the source address, it will now be where is it? The IP address, my IP address, and then the destination IP should be the IP address of the receiver. So how do I see it? Come to this second frame here. Can you see where it says Internet Protocol version 4? So I'll click this arrow here. If I click this arrow here, you see this is version 4. And then let me scroll down here. Very good. Can you see where it says source address? This source address here is the same source address that we see here. And it's the same source address that we have that is still pinging. Let me end it. All right. So if I do IP config, Okay, so you see 28.192. That is the IP address that I have as my source. My destination is 28.106. Okay, my destination is 28.106. So here you see my source is 28.192. The destination is 28.106. It's the same thing up here. You see source 28.192 and 28.106. Okay, so that's the first thing that I want you to know. So it's like somebody goes into your network, connects, runs Wireshark. He can see a lot of traffic going in through. He can filter it based on the protocol that he wants to get information, and then he can now investigate to get some data. Let's go back to the activity and see what else we're asked to do. B says, with the PDU's frame selected at the top section, navigate to the middle section, which we just did. Click the plus sign to the left of the Ethernet row to view the destination and source MAC addresses. Good. So now we have seen here, we have seen the IP addresses, right? This is the IP addresses. That's layer 3. Now, the MAC address is under this Ethernet frame. If I click this Ethernet frame, you can see the source MAC address. Can you see the source MAC address? Let's compare it with the MAC address of my system. You see this one ends with 0D880. So let me come for one for my system. Right, so look at it, see the MAC address of my system. And if we are to compare this MAC address with this one here, you will see that it is the same MAC address. It's the same MAC address as the source MAC address, okay? The destination MAC address, this is the destination MAC address. That is the MAC address of the router or the system I'm pinging. I'm pinging my phone. So that's like the MAC address that is there. Okay, so we have seen that you can get the IP address, you can get the MAC address. Okay, let's see else. All right, it says, does the MAC address match that of your PC? The answer is yes. Does the destination MAC address match that of your teammates? Yes. All right, so we have gotten that. Part 2 says capture and analyze remote ICMP data. All right, which means we're going to now ping maybe Yahoo. We're going to ping Yahoo or Cisco or Google. So we're going to ping a remote site. Once we ping a remote site, we're going to find out what information we can get out of that. Okay, so let's go back to our, this is it. So we're going to now start the capture again. All right, so I'm going to start capture. I'll exit without saving because I don't need to save it. Then I will come to my command prompt here, and then I will now ping let's see, google.com. Okay, you see the moment I'm pinging, it has begun the capturing. Okay, so I've stopped it. Then I'm going to ping Yahoo. You're going to now see the difference, yahoo.com. Right, so it's going to continue different sets of IPs. Then I'm going to ping cisco.com. It's going to continue with another different set of IPs. Now, you see, we have captured ping of different sites. So which means we should have the same source, but different destinations. Okay, if we investigate it, for instance, the first one we did for Google, this is the source. You see the source is my IP address, 28.192. But see the destination, 172.2 217.20.206. All right. How do I know this is Google? Very simple. I can pick this IP address and launch it on a browser. I should be able to see Google. All right. So let's find out. So let me, where's my browser? Let me launch my browser. Okay. And in the browser, I'll just type this IP address. Can you see? There's destination 172.217, 172.217.20.206. And I press enter. Okay. Now, this IP address we said should bring us to Google. Can you see? It's bringing us to Google. But how is it that we only typed an IP address and it's bringing us to Google? If we type the domain name, brings us to Google, because there is an application service called the DNS. The DNS does the resolution of domain name to IP addresses. That's what the DNS does. Okay, it can resolve domain name to IP address. That's why when we pinged Google, it gave us a number, an IP address. Okay. Now, we also pinged Yahoo. See, the destination IP address for Yahoo is also different. 98137.11.163. Okay. The same thing, assuming I don't even know, I want to find out, I can even just come here or here in the Google, I say, who is, let's type the IP address, 98.137.11.163. Because assuming you are a network administrator or security expert, and then you are just seeing this IP address, you don't know who the IP address is. You just say who is, and if you press enter, all right, let's see what it's going to tell us. All right, so it's going to bring us some websites to find out about this IP address. So if I click this, let's see what it's going to show me, for instance. Okay. Let's see whether this website will give me information. It's telling me where the website is domiciled and things like that. And this, it's giving me the details about the website, but I don't see it telling me who owns the website. So maybe this particular site is not going to give me what I need. So I will go back and check other sites and see. There are actually application, web application that that can give you these details. All right. Our own that we use is called Afrinic. So Afrinic can give you that, but you need to have a particular account with Afrinic. So we're looking for who is, we want it to, it's telling us where it is located, but we need to know who owns the IP address. All right. So let me say who is 98.137.11.163. Okay. So let me see, open here. And let's see whether we will get any information. Aha. So you see this particular site has given us. And you see it's telling us that who owns it? Yahoo owns it. All right. Yahoo owns the IP address, and it's telling us the date that they registered the IP address in 2007, and they updated this IP address in 2019. Okay. And it's telling us the address is going to be in New York. And let's see. It's even telling us who is the handler and some details and the name of the person that we can contact and the phone number of the person and the email address of the person. This is the second person, the tech person that we can contact. So you see, just by going to the general website, we're able to find out who the owner of this IP address is, okay, by saying Yahoo. And then we can go down again and see the other one that we tested for Cisco. Where is it? I think we tested for Cisco, something like this. This is the IP address. Okay, so you tested for it. So in each case, if you want to find out, you can come down here and then see the details of the source address. This is the source address. And then this is the destination address that you have, right? So, all right. I think basically that is the activities that we have for today. And this is where we'll draw the curtain for today's class. I will open find out if anybody have a question. You can raise your electronic hand, and then we'll be able to see if we can attend to the question. So while the question and answer sessions is going on, I am going to open up the channel for attendance. A number of you have contacted me, a few, maybe like 2 persons, that they didn't see their name in the attendance list. And please, I am not the one that writes your names for attendance. The attendance list is generated as you sign your attendance. If you don't sign the attendance, your name will not be published for attending today's class, even if you actually attended the class. So let me appeal to you once again. You please take note. I'm going to now give you opportunity to sign in your attendance. All right. Okay. So before I take the questions and answers, let me open up this thing for attendance. Just be patient with me. And then remember, once you sign the attendance, do not exit until we close the attendance. If not, it will take your name out. All right, so you should be able to see a notification on the attendance. You should be able to see the notification there. All right, so while you're taking the attendance, let me take in your questions. We have the first person here, Omoni Wale Salami. Please, sir, unmute yourself and ask your question.
Yeah, thank you, Engineer Tabe. My question first, please, when I log into WebEx, I couldn't see that group that you said you created for us. Then please, I didn't know which of the practice file you use for this Wireshark. I check it in the downloaded this, I couldn't see it.
Okay, thank you very much. For the practice lab for the Wireshark, I'm going to add it to the link that I've given you guys. I think I forgot to give you that activity. So I'm going to drop even the other activities that you're going to see there. Okay. And then for the WebEx, let me share my this thing. What do you call it now? My screen once more. And then I'll show you about the WebEx. Okay, it's a minute.
Okay, thanks.
It's loading. What's this? Okay, now this is WebEx. Okay, I'm sure you should be able to see the WebEx. And you see here, this is the class for, you see MBT instructor training class. And I had dropped a message here for the class. Now, see the people that are already in the class. I think about 243 are already in the WebEx. See their names here. I don't know what is, let me see. What is your own name?
Omoni Wale Salami.
Omoni. Okay. I can't see you. Right. Let me see. Omo. Under O. That is OM. O, this is K. K. Or salami. Can't even.
Yes. Salami is SALAMI.
The salami I have here is engineer OW Salami.
That's me.
That's you,
That is me. Yes.
So I can even
I'm
call.
on WebEx now and I cannot get.
Yes, I can even call you on WebEx. You see, I can even call you.
Okay, please do.
Is it ringing? Because it's showing that I'm calling you. You know, I can even call you on WebEx now if you are on, unless maybe the email you have given is different from the email that you are registering for the WebEx. Okay.
The email you saw there, that's owsalami@abu.edu.ng. That's the email I'm using.
Okay, so maybe I will sort out that and find out where the problem is. Okay, I'll find out that where
Okay.
All right.
Okay, I saw your missed call. Okay, I saw you. Yeah, I've seen your call as a missed call.
Okay,
let me call you back.
Very good. So you see.
I'm calling you now.
So, all right. So you see your
So
call.
I don't.
Your call came in, and I can see. All right.
Yes, I'm
You
seeing you as well. I'm seeing you. Yes, I'm seeing your face. But I don't know how to join that group.
All right.
Where will I click to join the group?
I will discuss that with you maybe much later. But
Okay.
Since you're already in, I think that is one problem solved. Okay.
Yeah. Okay. Thank you.
So you just go to messages and you will see the messages under NBTE.
Okay.
All right. The next person is Henry James. Henry James, can you?
Yes, sir. Good evening, sir.
Good evening.
Thank you for your presentation on the lecture, sir.
Thank you.
I just want to be clear, I need clarification on the difference between a source IP address and a destination IP address.
Okay, thank you very much. Okay, while I answer that question, so far I can see 4 people are yet to sign their attendance. 4 people, and the attendance will close in the next.
The attendance has not shown on my screen.
So the difference between source and destination IP.
I've not seen the attendance.
The attendance, you will see a poll under your app, under polls. You click it and then go to, you will see the attendance NBTE CCNA1 network class. Then click present. Okay. Right. So I can see the remaining 1 person.
I can't find it. Sorry, sir.
All right. So
yes, it popped up other days, sir, but today I can't see it.
Let me answer the question first. The difference between source and destination IP address is that every device that belongs to a network must have an IP address. IP address is like the identity of that device, like the ID number or the ID number, how that device is identified on the network. So a source IP address is the IP address of the sending device, the device that is generating the request or sending the message. The destination IP is this IP of the receiving device. So if you are writing a letter, all right, and you are writing a letter to your wife, for instance, so the source IP address is your own name. Then the destination is the recipient, which is your wife, for instance, her name. Okay, so that's just the difference between the two. Right. Okay,
So we are using this in the case of sending request to server and receiving request from server.
yes. So in the case of sending and receiving requests from server, the client sends the requests. Okay, the server now becomes the destination. So it's like saying
Okay.
like what we just did in the Wireshark. I use my system to run a ping, so my system becomes the source. Okay, the destination becomes the mobile phone that I am pinging. So the source is the device that is generating the request, and then the destination is the device that is being requested. All right. So basically, that is it.
Okay. So can you also clear me on how to sign the attendance, because today it did not pop up like other days.
So the attendants have closed now, but to sign the attendance, let me share my screen and show you guys how to do that. Probably maybe I should have done that, but I see everybody has signed, remaining one person, just one person that did not sign.
I think possibly that should be me.
From what I can see.
Yes.
Person did not sign. So you go down, if you look at your application, you will see where it talks about polls or quizzes. Can you see that? That is on your Zoom. Can
On
you see?
my Zoom, I
Yeah.
can't see anything else. I only see more.
And if you click more, can you see something like polls or quizzes?
No, what appears is captions, settings, stop incoming video, return to defaults.
Wow, that's strange. I don't know. I'm using system, so maybe using the phone, somebody may be able to help us. So just stay online. Let me
I'm also using
answer
system.
other people's questions. Somebody may be able to help us. Okay. So just stay online, Henry, please. The next person is Dr. Oho Stephen.
Sir.
You can ask your question.
Good evening, sir.
Yes, sir.
Well, thank you for your presentations. Thank you for your presentation, sir, for
Oh, you're
today.
welcome. Thank you, sir.
So I want you to throw more light on inbound and outbound.
Inbound and outbound.
Yeah.
Okay. When you say inbound, you are talking about traffic that comes into your network or into the device. When you say outbound, you are talking about traffic that goes out of the network or out of your device. So for instance, if I send a ping like what we did on the Wireshark, I am sending an outbound traffic. The traffic is going out of my system to go and test whether a particular system exists. And once that particular system exists, it will send a reply back to my system and it will come into my system as inbound. Okay, so basically that is the difference. I hope that is clear enough.
Yeah, it's clear. It's clear.
All right. Thank you very much,
Thank
sir.
you. Okay, thank you.
All right. Then we have Samuel Ayamboye.
Yes, thank you, sir. Thank you for your presentation. I will really appreciate you, sir. The issue of attendance, I could see that the almost as I've participated in the meeting, second class and third class. So I could not even see my name in attendance. I think that one, well, I think that will be settled. Sir, the issue of Wireshark. I want to throw more light. One guy just put it on the chat that we should make sure that we use the authorized network. But if not, They can flag us, and that thing can be prosecuted. So I want you to show more light on the issue of wire sacks, sir.
Okay, Wireshark is a network traffic and analysis software or tool that you can use. Either is used for education or you can use for traffic analysis. Okay, so you can use it on your own hotspot, like I am using it in my home. All right, you can use it in your institution. You can use it anywhere you want to use it. All right. The challenge is that when you want to use it to sniff in an unauthorized network, for instance, you go to somebody else's network, all right, and then you plug in your system to that network and you are running a particular analysis without authorization, they can flag your system and block it, okay, because it will be seen as a security threat. A lot of hackers, a lot of malicious users are using some of these tools to gain information about other people's network. So if you go to any network, maybe the network in your school, if it is your school, you don't have a problem. If it is your house, you don't have a problem. If it is a cafe, you don't have a problem. But that you leave your own house, leave your own school, and maybe you go to maybe the Nigerian military, and then you connect to their network and you are running this without authorization is a problem. Or you go to agency that you know that is security conscious in their data and you plug your system and you're running it, is going to be a problem. Okay. But generally, if you run it in these areas, you don't have a problem.
Okay, sir. Okay, sir.
All right.
Thank you, sir.
Thank you.
Yes, sir.
Farao Abubakar. So after Farao, we'll take Mary Chris, then Ado Stambogari, then Victor Oluwasegun, then finally Engineer Samuel Oloche. We'll take it in this order and then we close for the day. Our time has gone. So go ahead, Farao.
Good day, sir, and thank you so much for a wonderful presentation.
You're welcome.
Mine is just a request to be added to the WebEx. Anytime I open WebEx, I don't see me being enrolled in any of the classes, as you mentioned earlier.
WebEx or
yes, WebEx.
Okay. All right, but you have installed WebEx. Have you installed WebEx?
Yes, sir.
Okay. Let me see. I can see Faru Abubakar is already installed here. Let me even calling you. So I'm right now calling your device now.
Okay.
Your device now. So you are
Yeah, I can see your call, sir.
So which means that you are there.
So, but anytime I open it, maybe you send us a procedure to join the class, because anytime I open the WebEx, I don't see anywhere or any option to go to see the name of the class. I don't see anything.
All right. So maybe what I'll just create a short demonstration video on how you can use the WebEx to be able to interact with.
Yes. So thank you so much, sir.
You're welcome.
That's right.
All right, Mary Chris.
Thank you, sir. My own tool is also on the WebEx. So each time I open the WebEx, take me to join a meeting. So I don't know how to go about it. So I think maybe when you do the short presentation, maybe it will.
Okay. I just checked also. You are also here. I don't know whether your device is on, but all right. So I've also checked you, so you are also there. So I don't think there's much problem, but I will look into that.
Okay. Right. So when I open it, I only see join a meeting.
Okay. All right. So I will do a demonstration that will teach you guys how to use it then.
All right, sir. Thank you.
All right. Engineer Oloche.
Okay.
Well, but
Can you hear me?
Okay, since he's not available,
Yes,
the next person.
I am.
Okay, are you there?
Available.
Okay, can
Yes, I'm
you
here.
increase your volume?
Oh, can you hear me now?
Okay, go ahead.
Don't have much to say again. I think the question I wanted to ask was what Faru Abubakar and Mary Chris had
Okay.
navigating around the WebEx.
Okay.
Yes.
All right. Thank you very much, sir.
Thank you, sir.
All right. Anna Victor.
Good evening, sir. Thank you
Okay.
so much for the presentation. Quite
Okay.
interesting and exciting. My question is just a brief one and a quick one. Still on the White Shark application, you actually said you will drop it on the platform perhaps after this class. But what system specification or requirements does the Wireshark itself needs for it to function properly on our systems? Because I know some of these applications could be heavy and we don't even know the size. So I just want to know what system requirements do we actually need for it to function properly.
All right. So I will drop the details when I'm dropping the activity, the assignment. You will see the details, the minimum requirement that is required. Okay. I'll just drop that. You'll see, but it does not require so much. But I'll drop the details. You will see.
All right. Thanks.
Finally, Femi Ojo, and then we will call it a day.
Thank you very much. Thank you for the good job we are doing. Mine is just a brief contribution on the attendance.
Okay.
I am not using phone. I'm actually connected through my laptop. But for Henry or other people that are not able to sign, because I had similar issue in the past, what I noticed that in the window frame, immediately you make the attendance available. On the bottom part of the screen, you go to more, you click on more. Once you click on more, the moment you click on more, you will see the attendance flagged up there where you can mark present. Immediately you mark it, you are done. It's not as if it's captured on the menu there, but it will flag off once you click more during the period when the attendance is open. That's my contribution. Thank you.
Thank you very, very, very much. Thank you very much. So once again, thank you so much, class, for your participation in today's class. I hope this class has been very informative. I'm going to drop the recording on YouTube. I'll also share the YouTube with you. I'll be dropping an assignment for you guys to do. One, for you to join the ISOC, and then the other is for you to do the Wireshark installation. Okay. For those of you who don't get notification about the videos, when you go to the YouTube channel, ensure that you subscribe and then you click, what do they call it? Is it notification? And then you click like so that you can be able to get notified. If you have a question, you can still type it on the comment section and then I will answer you. Thank you very much and have a good night.